Graph linear equations. If you have graph paper, you may want it. You don't have to have it, but a solution of an equation in two variables would be x and y, and it is an ordered pair x, y, which is what we talked about yesterday, the ordered pairs, that produce a true statement when plugged in for their respective variables. A linear equation is one whose graph is a line the standard form of a linear equation is ax plus by equals c.
Butchering.
Go down to the library and tell Miss Samuel that you are taking the test, and she'll have the table at the front for you, so she'll make everybody else be fine in there.
Okay. Equations of horizontal and vertical lines so if I have a graph, I'm going to go ahead and set up. I'm going to have two graphs. Do them side by side. So if I have a graph that looks like this, with the point 0b on the y-axis, the equation of this line would be y equals b. The graph of y equals b is a horizontal line that passes through the point zero B. So that is a horizontal line. Okay, horizontal, it's like you're laying down. Vertical line goes up and down. And it has the point A0. And the equation of a vertical line is x equals A. So the graph of x equals A is a vertical line that passes through the point A0. So our first problems say to tell whether the ordered pair is a solution of the equation. So number 4, we have the equation 3x minus 2y equals -5. Then they have a little semicolon and the point -1, 1. Okay, so that's our ordered pair. And so we're going to plug this in and tell if it is a solution or not. So I plug in -1 for x and 1 for y. So this is going to be 3 times -1 minus 2 times 1 equals -5. So I need to see if the left side is equal to the right side. So 3 times -1 is? -3. And -2 times 1 is? So -3 minus 2 equals -5. -5 equals -5. And so that is a solution. So you just need to write that it is a solution. You can abbreviate solution like I do. If you want to write the whole word out, that's fine. But you've got to show this step. Okay? You don't necessarily have to show this one right here, this middle one, but you have to have this one, and then you have to have the final down there to get full points on something like this where you're plugging the numbers in. I mean, I'm not going to take it away, but I'm going to do the next problem. Number 6, y equals -7, and the point is -7, 0. So what's getting plugged in for y? 0. So this is going to say that 0 equals -7. Is that true? No, so this is not a solution. Number 8, -5y minus 6x equals 0. And the point that we're plugging in is -6, 5. So what gets plugged in for y and what gets plugged in for x?
-6 is for x and 5 is for y.
Yep, so I've got -5 times y is 5 minus 6 times x is -6 equals 0. What's -5 times 5? -25. And what's -6 times -6?
36.
So -25 plus 36 equals 0. So what's 36 minus 25? 11 equals 0. So is that a solution? No, not a solution. All right, the next thing we're going to be doing is graph the equation. So this is where you may want your graph paper if you have it. When we're doing graphing the equation, you must put at least 3 points on the graph. Unless it is a horizontal or vertical line. Okay, so if it's like x equals something or y equals something, like just that, you don't have to, but otherwise you need at least 3 points on your graph. All right, so number 12, we have y minus 2x equals 5. So what we're going to do is I'm going to plug in an x value, and we're going to figure out what y is equal to. So it's kind of what we did at the end yesterday, except for they gave us values that we had to pick. On this one, you can kind of pick your values, but I would stay in like the -3 to 3 range when you're picking numbers. So I set up a table. So I'm going to say that x is going to be -1, 0, and 1. And I need to find y. So let's see. Let's do this. Let's get y by itself first. So y minus 2x equals 5. How do I get y by itself?
Add 2x to 5.
Add 2x. So I have y equals 2x plus 5. Okay. So when I plug in -1, I'm going to have, I'll do it in here. Y equals 2 times -1 plus 5. So what is 2 times -1?
-2.
And then plus 5?
3.
3. So this is going to be the point -1, 3. Next, I'm going to plug in 0. So y equals 2 times 0 plus 5. What is that?
5.
5. So this is the point 0, 5. And plug in 1. Y equals 2 times 1 plus 5, which is 7. So that's the point 17. So I am going to graph this now. So I'm going to set up a graph here. And I've got to plot these points on here. So at -1, 3, so that's, and I need to, hold on, I need to label this. So I just need to show that it's 1 in every direction that I'm going as far as labeling. So at -1, 3, so -1 and up 3. At 0, I'm at 5, so 3, 4, 5. And then at 1, I'm all the way up at 7. So that's my 3 points, and then I need to connect them, and they keep going on, so we put arrows on the end of them to show that it keeps on going. So the only real difference between this and the ones we did at the end yesterday are that these ones we're actually graphing a line instead of just plotting points, so we're connecting the dots, pretty much is the only difference. Now, if you are doing this without graph paper.
Hey Stacy, Coach Hunter asked if it was okay if we can take the bleachers out if we wanted to put them in, keep them in.
Basketball's practicing, so I'm not sure.
Okay, so should I just tell her to keep them in?
I would say to keep them in for right now, and we'll pull them out closer to game time.
Okay.
Thank you. All right, so if the graph lines are gone, can you tell where these points are?
Yeah. I can. Just number them.
I don't think so.
Wait, I can't see.
I mean,
I can't see the
yes.
lines no more.
I have one sheet of graph paper.
That has nothing to do with how many sheets of graph paper you have. But I guarantee you can't tell me what that point is right there because there's no lines on here.
Oh, I knew someone was up.
Okay? So, if you don't have lines, then what you need to do is you need to mark off lines. Okay? Now it's going to look weird when I go put this back on. But notice, this point over here, -1, 3. Okay? So you need to put lines on there before you do that. Otherwise, it looks like this, and nobody knows what the points are on your graph. Nope, not that. That looks like okay? So, I would say if you have one sheet of graph paper left, what you should get in the habit of doing is by marking off the lines so that it's clear what things are. Because now when I take away my grid lines from here, you can clearly tell what all those points are, right?
Yes.
Yes. So if you're using notebook paper or plain paper, anything but graph paper, you have got to make sure that you put these marks on here. Okay? Any questions about that? If you are out of graph paper and you need some, I'm happy to go online and print some for you because you can print graph paper from the internet. So you just have to let me know that you need that and I can do that. All right, number 14. Y plus 4x equals 1. So let's do this. First thing, is what I should have done on the last one, is get y by itself. How do I get y by itself? Minus 4x. So y equals -4x plus 1. So now I set up my x, y table. What numbers do you guys want to use for x this time?
-2, -1, 0.
-2, -1, and 0. Sounds good to me. Alright, so I'm going to plug in for x here. So y equals -4 times -2 plus 1. -4 times -2 is
8.
8 plus 1 is
9.
9. So this point is going to be at -2, 9. Plug in -1 for x. Y equals -4 times -1 plus 1. -4 times -1 is +4 plus 1 is 5. So this point is at -1, 5. Plug in 0. Y equals -4 times 0 plus 1. -4 times 0 is 0 plus 1 is. So this point is at 0, 1. So set this up. I know I've got to go all the way up to +9, so I'm trying to make sure that I'm leaving room here. So I'm going to go ahead and mark off because if I take away my graph lines, I want to make sure I know where everything is. And I understand that y'all can't just take off your lines, but if you're not doing it, that way everybody's in the habit of doing it correctly. So the first point is at -2, 9. So -2 on the x and up 9. Make sure I counted right. 1, 2, 3, 4, 6, 7, 8, 9. Okay. At -1 on the x, I'm at 5 on the y. So -1, 5. And at 0, I'm at 1. And then I connect it. And I should put my labels on here so that I know that these are counted in increments of 1. All right, 16. 3y plus 4x equals 12. So first I want to get y by itself. How do I do that?
Subtract 4x.
So that's going to be 3y equals negative 4x plus 12. Then what?
You make your chart.
Nope, y is not by itself.
Oh,
Divide by 3, so y equals negative 4 over 3 times x plus 12 divided by 3 is 4. Notice I'm allowing you to skip some steps now that I wasn't letting you skip in the last section. If you still need to write out every time the minus 4x on both sides, divide by 3 on both sides, you should still do that. But if you are at the point where you understand that enough, which from what I graded on the test, it looks like most of you understand what's going on. So you can start to skip a few steps here and there. So now I'm going to give you a little trick. When I'm choosing numbers here for x, I would choose things that are in increments of 3. Why?
Because it's divided by
Yep, because it's divided by 3, so that means things are going to cancel. Okay, so I'm not left with fractions. So on this one, I would use x being something like negative 3, 0, and 3. Because then that's going to allow things to cancel. Okay? So y equals negative 4 over 3 times, remember that x is really on top, so negative 3 plus 4. So 3 and negative 3 reduce. So I end up with negative 4 times, don't forget this negative over here, negative 4 times negative 1 is, and then 4 plus 4 is
8.
So this point is at negative 3, 8. Plugging in 0, this one's the best one of all because when I do this, negative 4 over 3 times 0 plus 4 is 4 because 0 times anything is 0. So this is the point 0, 4. And then lastly, plugging in 3. Y equals negative 4 over 3 times 3 plus 4. So again, just like the first one, the 3's cancel. This time this 3 was positive though. So negative 4 times positive 1 is negative 4. Plus 4 is 0. So this point is at 3, 0. So now to graph this one. Put your little marks on the graph. These are increments of 1. Oh, can't see it. All right, so I've got the point negative 3, 8. So negative 3 on the x up to 8 on the y. 8. When x is 0, y is 4. So 1, 2, 3, 4. Then when x is 3, y is 0. So over here, x is 3, y is 0. There's my 3 points, and I can connect the dots. And obviously my iPad makes the line straight for me, but I'm not gonna like get out a ruler and make sure it's like perfect. I mean, don't give me a graph that looks like that, but you know, if it's like something like that, it's close enough. I mean, I'm not gonna like get out and be like, oh, whatever. If you have like the side of your book or another piece of paper or something, you can do it, or a ruler. If you want to make it perfect, you can, but I'm not looking that closely at it. All right, 18 I want you to try on your own. It'll be just like the one we just did. I'm going to walk around and see how we did, and then we'll do 2 more things, and then we'll be done. 3x plus 2y equals 8. So you need to get y by itself first, and then you need to solve it out, or like find the points and graph it. take a couple minutes and do that.
I have a question. If I'm timesing it by 0 minus and like subtracted 4, it's just gonna be -4 or nothing. -4?
Yeah, 0 minus 4 would be negative 4.
Okay.
You're right. I don't think that number is right, but your graph looks more or less right. This is supposed to be +4. Should be a +7. And this one's not right, the middle one. Oh, you plugged in. Oh, okay, hold on. 2 is, this should be a +1, not a -1. This one's right. -6.
That's right. Cause
That looks right though. But then where's your graph?
oh, we're supposed to graph them too.
Yes.
That's what we were just doing. Were you not paying attention?
Oh, video.
That should be +4, and that should be a 7. That one I don't think is right though. I don't have that one done, but.
Look at yourself. I'm sorry.
All right, so what did we get when we solved for y, when we got y by itself?
Y equals -3/2 + 4.
So where's the x?
The x is gone.
X is not gone. X doesn't disappear.
I forgot to write it.
So it's gone on your paper, but it's
Yeah.
not actually gone. Okay. All right. So with a fraction of -3/2, what numbers would have been smart to plug in for x?
Multiples of 2.
Increments of, multiples of 2. Okay, so something like 4. Obviously the negatives work. 2, 0, anything like that. So I did -2, 0, and 2 because that makes it cancel the most. And it makes the easiest math. If you did something different, that's fine, but your graph should still basically look the same. So I did -2, 0, and 2. When I plug in -2, 2 and -2 will reduce. That gives me -3 times -1, which is +3. Plus 4 is 7, so I had a point at -2, 7. Plugging in 0, -3/2 times 0, that's just 0 plus 4, so the point is at 0, 4. And then at 2, 2's cancel, so -3 times 1 is just -3, plus 4 is 1. So at 2, 1. And then I plotted the points, and that's what it should look like. I saw a few of you did some other numbers, which is fine. I mean, any increment of 2, I saw somebody had -6, 0, and 6, like that also works. I mean, 1 works, 3 works, it just makes your math a little bit more complicated. I try to choose the numbers that make it the easiest. So, any questions on this one? All right, one other little trick I'm going to show you, which is kind of like giving you some like top secret information that you don't know yet. But what do you notice about this graph?
Straight.
Okay, it's straight, but where It's kind of, if you look at it, it's angled down, like it's going like down a mountain, right?
Yeah.
So notice this number was negative. Okay? The number in front of x was negative. Up here, what's this one doing?
It's also going down.
It's also going down. And this number was
Negative.
negative. Up here, this one's the same way. This one, what's this one doing?
It's going up.
It's going up, and the number in front of x was positive. So if it's positive, it's going up the mountain. If it's negative, it's going down the mountain. That'll kind of be your little, how my other classes would put it, cheat code when we get to stuff later on in this chapter. Let me just put it on my desk. Thank you. All right, the last thing in this section, and I know you don't normally end up having to go home with homework because you normally have enough time to do it in class. Unfortunately, today you probably will have to go home with homework. Number 20, y equals 0, okay? When you have something like this, you do not have to do a table. We only have to do the table when you have x and y values, okay? So, huh?
Isn't it just 0?
Where?
If y equals 0, then the thing is 0.
Which way is the graph going?
So it's gonna
Wait,
be
0
the
is
origin-
neither
the
negative
origin
or
is-
positive. I don't know.
So up here, we said when I have y equals some number, it's a line going straight across like this, correct?
Oh,
So,
Oh, I wonder if
y
it's-
equals 0, when I can get all the way back down here, that means it's horizontal at 0. So this is just happens to be on the axis itself, and that would be the equation at y equals 0.
Do we have to put a dot in the middle or not?
You can if you want, but I don't care. So that's why I was saying these are the only ones you don't have to like plot 3 points. Now, I could still say, well, you could plot 3 points because I could say, well, here's one, and here's one, but you don't have to have that. Okay? How about 22? X equals 2. What is that going to look like?
Horizontal. Vertical. Oh.
Where?
2 on the
Oh.
y-axis.
On
So
the
if-
right side, on going like from the top of quadrant 1 to quadrant 4.
Yep, so this is x equals 2, so that means technically I have a point at 2, and it's just a line going up and down. It is a vertical line like that. All right, any questions about any of this?
For like the second one, are you supposed to label that it's like the second point? Like, are you supposed to write a 2 there?
What do you mean? Like putting the little tick marks on here?
Yeah.
I mean, yeah, I should be labeling them. I'm just getting lazy. Since I have graph lines, I'm getting lazy. But if I didn't, yes, I should be. I mean, I really should be even on the graph lines, but yes.
Can I use my
Yes, let me write down the homework first, and then you can do that.
homework? Elliot. Elliot.
All right. 3 through 25 odd. Okay, 23 and 25, they're like matching, so you probably should do 24 also, but I mean, it's not really going to make that much of a difference. I can just look at the graphs and tell you which one's which, and you probably can do the same thing on 23 through 25. There's no work for 23 through 25. There only is on the other ones.